Thank you. Hello, hello. Yeah. Okay.
ठीक है
Cool.
और ये ना थोड़ा खोल के रखो ऐसे ये थोड़ा खोल के रखो
Okay. Cool. Cool. Hi guys. Hi guys. Good morning. Good afternoon. How's it? I hope you are good. There is a buzzword, Fast API. It's going from LinkedIn to your blogs, Google Chrome, Edge. It is going everywhere. It is getting popularity. So let's see, is it fast as its name suggests? Let's see, you want to deploy a machine learning model. You got your code, you did training, and you want to earn some money. Let's say you want to create a software as a service product. So everything is ready, but how to deploy it? How to deploy it is an API, so other people from the world can use it easily. So how to do it actually? In the market, there are many frameworks: Fast API, Flask, Pyramid, Django, so many. So it's confusing. What is best for me, or what is fast, or which framework is giving so many features? By using it, I can deploy my machine learning model very easily and I can earn some money. So you want something which is fast. The speed matters, whether you want to create a small API or a big API. Speed matters. You also want something which is lightweight. You do not want that your AWS bill will get to a higher range. So you want something lightweight. If something is lightweight, then you can scale very easily. It do not require so much time to spin up a new server or a new container, because we are living in age of containers. Also, you want productivity. You do not want to get into the realm where you want to just do the configuration, writing classes, do this configuration and this configuration. You want, okay, I got this thing, I just want to solve it, I want to create an API from it. So you want something which will give you productivity. And one more important thing, you want input data validation. If you are a developer, you already know how painful it is. If you have not added input data validations, then it will be nightmare. So let's say you create an API for your machine learning model. So anyone can use it and they will just put it anything into it. So if you do not have data validations, then on your backend servers, it will be just so many server errors of data validations. As well as you want fast deployments. DevOps guys will love this. So if you are a DevOps guy, you want things which are very lightweight as well as it's easy to deploy. One more thing, let's see, you have created an API, everything, but how you will explain to someone like how to use this API? Are you going to create a PDF and you will share it to the world? No, you want something which everyone understands. All developers, even any non-technical person will understand. So there is one open API schema which you can use. So if you have created the open API schema and if you give it to someone, they will understand, okay, this is the API, I need to give this input and it will give me this kind of responses. So solution, fast API. I gone through so much research and then I found fast API and it was fast according to me. But is fast API really fast? Yeah, that's a big question. We are going to say it. Wait a minute, like who am I who is saying like fast API is fast? Myself, Princekumar Dobariya. I'm software engineer at BBD. I did 2 certification, Microsoft Azure and AWS solution architect. I mostly closely worked with Azure. From my academic background, I did instrumentation and control engineering. I worked in chemical plants. Then I got bored. I was like, I want to do something else. Then I written some programming ladder logic to program the PLCs, which actually do the automation into the industries. Then I was like, I need to get into the IT domain. So that then I got an internship opportunity in BBT. And after coming to the BBD, I actually got something called cloud. On my academic days, I only heard about like, okay, this is AWS, this is Azure, this is Google Cloud. But how to use it? What is it actually? So when I came into the BBD, I got an exposure and like I really worked into it and I'm into it. So in my previous project, my tech lead gave me one task. We want to build this feature. So can you just do it? We need to create an API. How to do it? So I took some days because I knew I was new to it. But then done and dusted, as usual. Then he came to me and he told me, can you document it? I was like, how to document it? So I written something into PDF format and I told him, okay, this is the documentation. He was like, no, you want to build this kind of swagger schema so everyone in our team as well as other people can understand it. How many of you have seen this swagger schema or yeah, most of you are developers, so yeah, that's good. Because when I saw it first, I was like, how to do it? Then he told me like, you do not need to write HTML code, you just need to write some of the YML configurations. I was like, how to do it? I just googled it, then took some days, done and dusted. But there was one question, like, is there something I do not want to write the APIs? I want something that my framework or any program, it can automatically generate the Swagger schema for me. I do not want to write this configuration. I just do not want to waste my time. So yeah, it was very good question. So it came into my mind until I discovered Fast API. Fast API, it's modern, it's based on Python, and it is following standard type ends. If you're a Java developer, you already know, like, you always need to write the types. But in Python, you do not need to. But in Fast API, they build in a way that it supports Python standard type ends. It's not something like you need to install a third-party library. It will come by default, and it is fast. Believe me, it is fast. You can try it out. It is fast to code. In screen, you can see, like in few lines of code, you can just create your APIs. Okay. Authentication, other things are not there, but still, in few lines of code, only one file, you can just create your API, whatever you want to do. There are very fewer bugs. So as a developer, whenever you are building something, so you're always worried about like, is it popular? Is it getting good community support? Are people using it? So with Fast API, I actually gone through the repository of Fast API and I discovered there are very few bugs. Most of them are just queries like how to do it or how to use it or is it supported. So there are very few bugs. So you can actually trust it. Intuitive code completions everywhere. So as Fast API is supporting standard Python typing, so whenever you're writing Fast API code, whether you are using VS Code or PyCharm, you will always get code completion because it is following Python standard typing. So if you are writing, if you are directly using a Python class, and if you have defined like, okay, this field needs an integer. So when you are writing the code, it will give you auto completion. Okay, this will needs integer. So you will get auto completion. It's Python, so it's easy. You do not need to learn so many days. In one day, I think you can create any kind of APIs with Fast API. Robust, and you will get production ready code. It out of the box come with the data validation. You do not need to do the data validation. Yes, you need to write some classes, but no, you do not need to write some of the messages hard codedly. It will also get the type checking, which kind of parameters you are getting. Authentication and security. It is not coming out of the box like the Django. If you have used the Django, so you know, like Django takes care of everything. But you will get some of the utilities of authentication and security in FastAPI. And you will also get dependency injection. If you are a Java developer, you already know it. And highlighted thing, automatic Swagger schema for you. As well as how fast API is getting its speed. It's thanks to the asynchronous support in Python, and which is leveraged by the fast API. Also, because of the Starlet, which is a small framework, which is used by fast API directly. So you also get the middleware support. Okay, you want to write some of the middleware things, you want to do some manipulation in your HTTP header. So you can write your middlewares out of the box. As well as you will get multiple database integration, whether it's MySQL, PostgreSQL, even it does supports GraphQL. You might need to use one of the third-party libraries suggested by FastAPI, but yes, it does support. Easy deployments. In this stage, you do not want to just go into, okay, I want to do this configuration, I want to run this thing. So you do not need to worry about the configuration, how you will deploy it. Just run FastAPI, run app.py, which is your main file. It will directly run your FastAPI into production mode, not even development mode. If you use the Django, in Django, if you run python manage.py run server, which will basically run a development server. In one of my project, I was like, in the project, they were using python manage.py run server in production. I was like, this is not gonna work. So in FastAPI, you will get very easy deployments. You can use it with UVCon, Gunicon, even you can deploy it on basic Linux server. Even it does support the Dockerization. All of the things, in whichever way you want to deploy, you will out of the box will get a tutorial. If you go to the documentation of it, you will directly get the tutorial of like how to do it with this configuration or with this way. And this is the thing which I love the most. The moment you start writing your API code, FastAPI will take care of it to create a documentation for it. You do not need to write .yml file or JSON schema. You just need to focus on your business logic. Just create some classes, or you can just directly use some query parameters or path parameters into your APIs, and this kind of documentation you will directly get out of the box. Even in your URL, you do not need to write some routes for it. FastAPI, all batteries included. It comes with UVCon, Pydantic, Starlet, and highlighted thing, OpenAPI, Swagger schema. So these are some of the components which is basically used by FastAPI to create this kind of framework which will give you so many features. FastAPI. So what research actually I did? Actually, when FastAPI got created, his creator took inspiration from so many frameworks. If you are a Python developer, you already know many of the frameworks looking onto the screen, Django. So if you have used the Django REST framework, so you know when you use the Django REST framework, it will create a documentation for you, but it will not create in a way of a Swagger UI. So if you are Django developer, then you know, okay, I need to use in this way, but it is not creating into the OpenAPI schema. So creator of FastAPI took an inspiration from the Django, as well as it took inspiration from the Flask. How from the Flask? Flask is very lightweight and it is vastly used. And Flask and Django, they are like very old frameworks, mostly trusted by the developer. So Flask is lightweight. So creator of FastAPI took an inspiration from the Flask, like, okay, we also want something which we are creating. We also want lightweight. We do not want to make it so heavy. And also it got inspiration from the Falcon, API Star, and many bunch of frameworks. If you want to know like which kind of inspiration it took from the different frameworks, even it took from inspiration from the Angular itself, as well as Nest. They are JS-based frameworks, but still there was an inspiration from those frameworks. So you can go to the documentation and you will see like, okay, which kind of things were not present into this framework and which kind of inspiration taken from the. There is one statement, if you go to the FastAPI's documentation, very high performance on par with Node.js and Go. Don't kill me. I was not the one who said that statement. Let's see the benchmarking. How many of you have seen like benchmarking? There are any open source benchmarking. Like, have you seen it? The, like someone has did the benchmarking. Yeah, that's cool. Very few. I was also new to the benchmarking, like how they are doing it actually, and like what are the benchmarking in which parameters someone should benchmark a framework. So there is one company, Tech Empower, that back into the days, they were like, okay, there are so many frameworks. We need to say, okay, this is fast, this is slow, how it is fast, and which categories it is fast. So they created one framework which is Tech Empower Benchmark Frameworks. Is it open source? Yes, it is. On the screen, there is a QR code. If you want to see the code, like how they've written the scripts, how they've created this framework to benchmark multiple frameworks from .NET Core, Fiber, Jane, FastAPI, any open source framework. I'm not talking about like any close or like an internal. It's open source. So there are multiple categories. Like let's say if you want to check how your API is fast, what you will do? Hello world. Okay, let's see there is the result. In how much time it gave me the result? Okay, this is fast. This is not fast. No, there are also multiple categories. Let's say if you are working on production. So in production, you are not going to write, okay, hello world. You need to do multiple database queries. So you need some categories. So first category is JSON serialization. It's simple. You got one Python object and you just want to give it as a response. It's just basically converting your Python object into the JSON format. So you will give it as a response. Another one is single query. Let's say you want to query one post from your backend. So we'll just say, okay, this is the post ID. Give me the result. Another one, this is the most famous category which everyone is using in their production, multiple queries. So let's say you want to query one data, but there are so many validations or there are so many tables. You also want to take data from it. You want to validate, okay, this item should be also in this table. And when you're doing multiple queries into database, whether you are using raw SQL queries or you are using ORM, but you are doing multiple queries in only one API request. So this category suggests that. Another one, Fortune, it's simple. It's just like getting the data from the database and converting into the HTML template as a response. Another one is data updates is also simple. You want to change your name, you will say, okay, this is my user ID, change your name. Another one, plain text. Everyone has written this hello world whenever they have started the programming. Another one is caching. It's just getting the data from your Redis or in-memory data. So when they actually did the benchmarking, what kind of environment they've used? Did they use the physical servers or cloud servers? So they did this benchmarking on different ways. They use Citrix servers on their on-site, and they've also used the Microsoft Azure as well as AWS servers. It's enough about this configuration and that show me the result, because for that all we are here. Like you want to see like fast API is fast or not. Let's see. In the plain text, simple hello world, Fiber and Gin, they are just winning. In screen, you can see with how much margin it is just winning. So how they are actually doing this benchmarking? So they are using one tool which is WRK, which is open source. You can also do it. So they run this benchmarking for each framework for particular time duration. If you go through Tech Empower's website, you will see, okay, these are the configuration used for all frameworks. You will also see whether they've used ORMs or not. So which results I took? I took the results where they are mostly using the ORMs, wherever the results are available. So Fiber Engine, they are Go-based framework. So they are just winning it. Fast API is way behind. No. Let's see. We will see like where Fast API is beating. Even we can see FastAPI. FastAPI is Node.js based JavaScript based framework. So it is also beating Fast API. But you can see Fast API is beating Express, Flask, and Django. So in Python world, it is beating, but still it is not beating Falcon. So if you go through that benchmarking, so with Falcon, they have used different servers. So it is giving different results. So still bit confused, like Fast API is fast or not. Let's see another one. Single query. You want to get a post, you will get ID. Okay, API, give me the result. Fiber and Gin, Go-based language, again winning. Fastify, again beating Fast API. But still, Fast API is beating Falcon, Express, Django, Flask. You can see if you are using Django, so Django is so slow. It's so slow because it's heavy and there are so many features in it. So it is becoming heavy and it is slower than Fast API with a great margin. Let's see multiple query results. This category we are using mostly in our production workloads. So in production workloads, Fiber is again winning with the Flask. Flask is beating Fast API, but still Flask was used with the row SQL queries. It was not used with the ORMs. So if you are using the Django or any kind of framework, most of the days we are using ORMs because it is giving some of the productivity. But still, we can see Fast API is beating Gin, Fastify, Falcon, Express, and Django. So here comes the most interesting part where Fast API coming into the bold port. Like it is not like beating Gin with a great margin, but still it is coming into the picture like where a Python-based web frameworks can give big like a higher performance and it will give you ability to create the fast APIs. Let's see the Fortune results. In Fortune results, again, Fast API is beating Express, Flask, Falcon, and Django, but it cannot still beat Gin, Fiber, and Fastify. Still, it is coming into the ballpark where Node.js based framework, Fastify, Express, they are giving the performance, and like Fast API coming into the picture, and like it is giving, okay, I can also give the similar performance. Let's see the data updates. In data updates, again, Flask is beating Fast API, but if you go to the Tech Empower's website, to be clear, I have taken all of the what can I say benchmarking result from the Tech Empower and the results they provided. With the Flask, the results were bit confused for me as well because the data was not available. But let's leave the Flask. Let's focus on the Fast API. Still, Fast API is beating Fastify, Falcon, Chain, Express, and Django. So it is coming into the ballpark. There is one statement some people doesn't like, on par with Node.js and Go. Yeah, it's a bit controversial statement, and there are also some of the public threads on GitHub. Like people want like, okay, fast API, Python-based language, and it can beat Go and Node.js. No. So there was one person who was not also happy with this statement. So what he did, he created the same API in Fast API Express, and he was like, okay, these are the benchmarkings. Can you see the result? Fast API cannot beat the Express. I think we have also seen that. In plain text results, Fast API cannot beat Gin, Fastify, Fiber, but it can beat Node.js based framework like Express as well as Django. In the multiple queries, so this result is of the round 23, which was published into 2023. So on the results, we can see Fast API is actually beating Fiber, Gin, Fastify, and Express with a like higher performance improvement in the Fast API. How it got the higher performance, we'll see into the next slides. But still, it is beating some of the frameworks. Data updates, again, it is beating Fastify, Gin, Express, coming into the ballpark again. So, okay, enough about open source benchmarking. I was also like, okay, these are your benchmarkings, but how do I test it? So what I did, I created AWS setup. I got a bill yesterday because of running EC2 as well as RDS. If you use AWS, you know how big is the bill. So what I did, I created two EC2 instances. On one, I ran the WRK tool to benchmark. On another one, I ran each frameworks one by one. And on the database side, I created a RDS for the PostgreSQL. Let's see the result. Results were shocking for me as well. On the plain text, Gin beating, Fastify beating, but still, Fast API is coming into the ballpark and it is beating Express, Flask, and Django. So these are my results, not any open source result. So what I did, I took code from the Tech Empower's framework and I converted everything into a repository, like where I can run the benchmarking. Their configurations were different, but still, I took those code and I ran the benchmarking. In the JSON result, again, Gin baiting, Fastify baiting, but Fast API still baiting Express, Flask, and Django. So we can see these are the real results. On Fortunes, Jane is way higher. It's way higher because it's Go based. Fast API still coming into the ballpark. It is beating Django, Fastify, Flask, as well as Express. On the single query, again, my results are much similar to the Tech Empower. Jane, Fastify, they are leading. Even here is come the most interesting part. On the Tech Empower, Express.js was a bit slower than Fast API. But on my benchmarking, it was getting better. It was giving better results. It was high performant, but not that much of margin. So there might be different configurations of mine as well as Tech Empower. So Fast API is still beating Django in Flask. So in Python rel, it is winning. On the multiple queries, it is also a bit complicated. Fast API cannot beat Express as well as Fastify. Even if you see Go-based framework, which is Jin, is lagging from the Fast API. So any compile time language can be like, it will definitely give you higher performance than any like interpreted type language. But still, Fast API coming into the picture and it is giving you better performance. Data updates, again, Fast API is somewhere in the middle, but Jin is winning, Fastify is winning. So we can say Fast API is not always on par with Node.js as well as Go-based frameworks. It's not always like, it's not like truth, like, okay, Fast API is just beating everything. So which one is the best then? There is one statement, is it fast? It always depends on which server you are using it, on which configurations you are using it, whether you are using Gnicon, Uvicon, like Apache, like which kind of server you are using to serve or run your frameworks. One more thing, we should not compare apples with oranges. So Python is totally having a different architecture than Go as well as Node.js. So if you run just Hello World in Python and Hello World in Golang based framework or Node.js, you will definitely get high results in Go because it is statically typed and it is compile time language. So it will be always faster than Python. So it's just, if we compare the frameworks with the Python, like all of the Python frameworks, and we can say like Fast API is faster than other Python frameworks, then it will be true. So it also depends like which kind of HTTP servers you are using to actually run your APIs or web framework. If you are using Jin or Fiber, so they are running on the Go-based HTTP servers. If you are running Django or FastAPI or Flask, so you might be using Gunicon or Uvicon. And if you are using, if you are running Node.js based framework like Express or Fastify, so you will be using Node.js based HTTP server. So it also depends the speed of the server, like which kind of servers you are using and how they created this server. So tomorrow, if there is a server which comes like, which is so much faster, it is just server is handling all of the requests very crucially and very fast. So if you are using fast API with that fast server, it may just beat everyone. So it also does depends on the servers. So fast API will say, I'm the fastest in the Python run. I've also seen it. But it is not just in terms of speed of API. There are also different factors you want to consider. It will give you pretty much decent performance. Well, you can just stay in your Python realm. Let's say you want to create machine learning model. So you won't use Java. You definitely need to go for the Python because there are a bunch of libraries got already created. They are already fast and they are, so if you want to deploy such kind of ML models, you definitely need to go for the Python based framework, which will help you to deploy such ML model. So we'll go with the fast API. So it is fastest in Python realm. Flask, Django, Pyramid, Tornado, Falcon. Bunch of frameworks, but fast API is fast. You can try it out. Highlighted thing, again, I think you are just getting bored of it. But we'll see how this API documentation are helping us. As well as with the fast API, you will get automatic data validation on requests and responses. So the moment you start writing your API code, you just need to say, okay, this is the class and I want this kind of data into my body. So you do not need to create a new view. You need to add that. No, you just need to add that into your API route. And fast API will take care of the documentation as well as the data validation. As well as it does supports the ORM, SQL Alchemy or Tortoise. With async support, it will give you a better performance rather than just normal one. So it is fast, but who created it? Back in 2019, Sebastian Ramirez got inspiration from other frameworks and he was like, I want to build something. So he created FastAPI, Typer SQL model, asyncer. So if you see on the GitHub popularity, so we can see Django was back created in 2007. But right now we can see FastAPI got created in 2019 and it took popularity very speed, like in very short amount of time. So now FastAPI is on the second rank in the Python framework. So it is getting popularity and it is getting support from the bunch of people. What are the pillars of FastAPI? Like how we are actually getting this kind of speed into the FastAPI. One is Starlet, which is directly used by the FastAPI, Pydantic, and UVCon. Let's see the Starlet. So in FastAPI, it is not everything configured into the FastAPI. They are actually using Starlet, which was back created to create asynchronous APIs into the Python. So Starlet is lightweight and it is supporting ASGI based, what can I say, it is a toolkit to create APIs with the ASGI schema. With the Starlet, you will get bunch of features which are just loaded. So FastAPI not implemented bunch of the features. So it is directly just using it from the Starlet. Another one which is most highlighted and which is like main crucial thing into the FastAPI, by which FastAPI is getting this speed, UVCon. It is ASGI based web server. If you have worked on the Django, so you know there is a Gunicon. So it is similar to that, but it is basically using the asynchronous gateway interface kind of a standard. So ASGI, there is also one thing which is WSGI, Web Server Gateway Interface. So in Web Server Gateway Interface, it will run one request one by one. So if your API has not completed the execution, it will not allow the second request to come and run the code. But with ASGI, it is possible. So UVCon is using UV loop. It is nothing but if you are Node.js developer, then you know like how event loop and asynchronous things are happening into the Node.js. So it's similar to that. But here in Python, this is UV loop. So back in the days, we did not have support in Python for the asynchronous functionalities. But with the async IO capabilities, now we got the support in the Python, like you can write the asynchronous functionalities in Python. So it is similar to the async IO, but it is different library. So UV loop is an event loop which is handling this kind of asynchronous gateway interface kind of functionality where your code will run asynchronously. So if a request come, so it will not just wait like, okay, this execution done, it will just put it into a queue and then it will run one by one. So it is basically replacing the async IO. It is fast. It is written in Python. So Python, if you worked in the Python, so you know Python. So Python is basically giving the ability to compile your Python code directly into the C language. So you know C is so fast. It's so fast. So your Python code will directly run into the C language. So this is how we are getting the performance. As well as it is built on the libuv. If you are Node.js developer, anyone knows what is libuv or like how it is utilized. So yeah, it was also new for me. So Node.js is actually using this libuv library, which is actually written on the C language. So the same library is used by the UV loop to perform this kind of event loop operations. Again, the highlighted thing, Pydantic. So this kind of open API, Swagger schema, data validation, who is taking care of it? FastAPI has not written the code for it. It is directly using one of the libraries, which is Pydantic, and it is taking care of all the data parsing, converting your raw HTTP request body to the Python understandable format. It is serializing the data, as well as it is also taking care of the Python standard type ends. You want something in integer, it should be. It should not be into the string. So you want to give some kind of validation messages. So how actually by inheritedly FastAPI is getting the speed. So let's see the main pillars. FastAPI. First is UVCon, which is web server. So in UVCon, we are using UV loop, which is based on ASGI. And ASGI is using async functionality. And UV loop was written in Python. So you are basically directly getting the speed of the C language into one of the Python framework, or we can say in the web server. On the second, Pydantic. So back into the days when FastAPI got created, uh, Pydantic was actually written on the Python language, but then they migrated it from the Python to Rust. So Rust is very popular language as well as it got a better speed. So in FastAPI, we are getting speed of C language as well as Rust directly. So this is how we are getting the performance into the FastAPI, as well as Starlet, which is giving the web capabilities to the FastAPI. But how does it work? Like one by one component, it is made up of different components. But how does it working? So let's say for an example, you have hit an API request from your Postman as well as from the browser. So how it will go through each step. So on your Linux server, on your containers, a web server will be listening, okay, on this spot, I want to listen something. So as long as the API request is coming, okay, UVCon will say, okay, I got the request. Then what it will do, it will put it into the UV loop to process it. So if new request come, it will not wait like, okay, this request is pending. I need to complete it first. What it will say, okay, give me the request. I'll put it into the UV loop, and then UV loop's responsibility is to execute all of the APIs. So what UV loop will do, it will say, okay, Starlet, this is the API request, do the routing and get into the fast API and execute the code. It will go to the Starlet, it will go to the fast API's main code, and from the fast API will look to the Pydantic. Okay, Pydantic, we got something. Pydantic will say, okay, what is the thing? So if there is a body request in a body, so what Pydantic will do? Pydantic will do all of the data validation as well as the serialization in Rust. So it will be very fast, and it will do all of the validation as well as if you have opened the URL for the JSON schema, it will create for you. If everything is fine, there is no validation error, it will provide it to the fast API, and then fast API will execute the main code. So up till this point, other parameters, or we can say components, they are coming in the picture and they are taking the role of it. So what other things fast API is bringing to the table apart from just only speed? Speed matters, but also let's say you have shorter time, you want to build a startup or you want to build an API. Okay, you learn something, but you want to put it into some real action. So you know, okay, this is working. So you want some kind of productivity, like in short period of time you can build it. Otherwise, it will take months and months to build it. So with Fast API, there is one cool feature coming with is path parameter. So in Fast API, you do not need to write bunch of configuration. Let's say you want to use item ID as a path parameter on APIs. What you need to do? Nothing. Just put it into curly brackets into Fast API, and Fast API will understand it. Okay, I just need item ID, right? I haven't provided the static type ends right now, but we'll see. So out of the box, Fast API will create this kind of Swagger schema for you. You do not need to write this kind of YAML configurations for your API. Let's see path parameters with validation. Let's say you want your item ID as an integer. So what you need to do? Nothing. Just add integer into your functions argument, and Fast API Pydantic, they will understand it. Okay, something is there and this validation should be this. So Fast API and Pydantic will again take care of it. You do not need to write this. Let's say for an example, if you have added, okay, you want integer type of path parameter in your API, but when the API got hit, someone has entered the string. So on the black window, you can see there is one message. So that message you do not need to write. Okay, this kind of parameter is not valid. Okay, so this kind of messages will taken care by the Pydantic as well as the Fast API. As well as on the screen, you can see the moment you have just entered, okay, I want item ID. So on the schema also, you will see like, okay, I want item ID. So if you want to show your APIs to any developer, so they know like, okay, I need to give item ID, otherwise it will not work. This is the cool feature, query parameter. If you're Django developer, so you know like you need to hard code some of the things. Okay, This is the request came, I need to get the query parameters from it. But in fast API, you can just write it as your functional arguments, nothing more. Just add it, just give it, okay, I want integer, string, boolean, whatever it is. Fast API will take care of the validation for you, as well as it will create the documentation for you. On the screen, you can see the moment you added just two arguments, it created the JSON schema for you. You do not need to write. Let's see another cool feature which I got so much interest in it. Query parameters. Let's say you want to build an API. In your API, you want to hardcode something like, okay, if limit is coming, I want it in this range. So if you are using other framework, so you actually need to write this kind of if statement. Maybe if you are Django developer, you might use some of the data validation method. You need to write all of the things. But in fast API, you just need to do import this query from the fast API, and you will just like greater than this, less than this. And even you can just add the description. In the description, the moment you added the description, fast API will understand it and it will create the JSON schema for you. As well as this greater than, as well as this less than limits will be validation kind of all of the parameters will be taken care by the fast API. If you had added the out of the range, you do not need to write message like, okay, if limit is less than this, okay, this is not the valid request. Fast API and Pydantic will take care of it. On the request body, is it also simple? Just create a class from the Pydantic and just put it into your API. Nothing more. Define which type you want. Fast API will take care of it. Let's see. I said enough about the ML model, how to deploy it. Is it easy? Let's see with the Fast API. Let's say you are done with your machine learning research. You have created a machine learning model which you want to deploy. So what you need to do, you can just dump it into pickle file, and in the fast API you can just load it with joblib or any kind of library. Just load it as a global variable, and in your APIs you can just directly use it, predict this, so you do not want to worry about anything. If you are using Docker, just mount the volume where your high like very big machine learning model is there. So deploying ML models with fast API, it's easy. So what about security? Yeah, security is very crucial thing. With fast API, it does not come with the facility like Django. So if you are Django developer, you know, like when you install the Django, you do some of the configuration, you will get, okay, these are the user tables, these are the group tables, these are the permissions, all of the features with Django. But in fast API, you won't get that. You need to write something. So with fast API, you will get the utilities, some of the helpful functions which will help you to build the secure APIs with the fast API. You can use OAuth 2, basic HTTP, username and password. You can even use the JWTs. Even you can implement the API keys. You can build in a way, in a secure way you want. Fast API will give you the ability. Another cool feature, let's say you want to run something in background. You do not want it will just run in your API. You want something, okay, I want to send an email notification to someone for this operation. For an example, let's see, I want to send an email to myself itself. So on fast API, just do it, and let's see example code. So I created one function, right, notification. So in fast API, this capability is actually coming from the Starlet itself. So Starlet implemented such thing like you can run your background task. You do not need to add this Redis as well as any kind of message broker. Just use this background task from the fast API and just put it as a dependency injection into your APIs and just do this, like just add task, put your functions, arguments, and fast API will take care of you. It will not wait to complete that whole function. It will run it into the background. So this is very cool feature. So what are the other features? Dependency injection, we have seen. You can write your custom middlewares in a way you want. Static file serve. So let's say you want to serve HTML file with JS, CSS. You can do it. Fast API does supports. The documentation of fast API is very detailed. If you go to the documentation, you will see there are each and every tutorials for the fast API, how to configure it, how to use it in this way, which database you want to use. And you can also write the unit test. So there are many techniques to get the best performance from the fast API. Let's see the one which I tried. Install UV loop. So whenever you are just basically installing FastAPI and UVCon. Just do the FastAPI, pip install FastAPI, pip install UVCon, and you are just running FastAPI without any other libraries. So what it will do, it will by default use the async IO from the Python. It will not use the UV loop directly. So if you just do pip install UV loop with the UVCon, then FastAPI will use the UV loop to process all of the ASGI based operations. So on the screen there is a benchmark. So this benchmark got done by the UV loop team, so creators of the UV loop, and they did the benchmarking. We can see on the screen that UV loop is giving so better performance than Python's by default async IO. It's a bit complicated, but on the chart we can see like it is giving better performance even with the Go if we compare to the Go line. So I did the similar thing. So I ran the benchmarking with UV loop as well as async IO. So I got a little bit improvement. So yeah, you can use the UV loop. With multiple queries, I got little bit more performance. It was not that much of great margin, but still it was an improvement. With single query, I got the same improvement. As well as with the data updates, it was giving me the better performance. So another one is you can actually use the HTTP tools to pass your raw HTTP request into the Python-based understandable format. So you just need to do pip install HTTP tools. You will get the performance improvement. And highlighted thing is use async wherever you can, but use it wisely. Do not use async capabilities of Python for the blocking IO kind of operation. Let's say you want to process a big file and you are putting just directly into your code. And so what will happen? Your server will just stop it until that big amount of IO execution is not done. So use it wisely, use it for the DB queries as well as for the third-party queries you want to do. So who is using it? So you want some trust. So FastAPI got a good popularity, Microsoft, Uber, Netflix, but and also there are a bunch of companies, big companies, like so many people are using it. So you can trust it. Conclusion, FastAPI is fast. It's fastest in the Python realm. If you're a Python developer, go give it a try. It will give you the development productivity. It will give you the speed to develop things fast, not only in terms of getting the performance from the fast API, but you will get this kind of features like automatic documentation of your APIs as well as the data validations. So this is the very highlighted thing. As well as you will get the speed and performance we have seen in the benchmarkings, as well as FastAPI will create a documentation for you. And according to the benchmarking, we can say FastAPI is not always on par with Node.js as well as Go-based frameworks in all cases. In some cases, it can give you the better results with better configuration. You can try different servers if you want to. But yes, it is fast and it is the time. Try using FastAPI. This is a website for the FastAPI. You can go there and you can see the bunch of documentation. Thank you.
Any
Any
questions?
Hi, Prince. Uh, you showed a lot of comparison between various frameworks based on Go, that Node.js, Python, right? I did not see any Java-based framework like Spring Boot. So is it like it's too old to stay in comparison, or you just did not consider it?
So for the benchmarkings, I just focused on the statement. But if you go to the Tech Empowers benchmarking, you will see in some of the categories, Fast API is beating actually Spring.
Okay.
Spring is, I think, Java-based framework. So it is actually beating the Spring. But with Java, I think most of the legacy applications are built on the Java. So if you want to migrate it, it will take so much time. So it depends again. So your applications are if stable in Java, then you do not need to migrate it. Let's say you want to build a machine learning feature or you want to use some kind of like, let's say Python. So I think at that time, maybe you can just create fast API for your one of the microservices and then you can use it. So if your system are stable, then you do not need to migrate it.
Okay. Thank you.
Yes. Any more questions? So,
Hi, Prince. My question is that you told us about the lot of advantages to choose fast API, right? Apart from speed, but which scenario you should avoid the fast API? Can you tell that scenario?
Yeah, with fast API, let's say you want to build the async feature, but with async features, like you need to take care of some things. Like let's say you have like big operation, as I've said in the last, like you have like very IO blocking operation. So at that time, you should not use the async. As well as if you do not use the async keyword before the function, before writing the function of the fast API, so what it will do, it will just directly run into the thread. It will not use the UV loop to process your request. So you can switch between like what kind of API you want to build. Let's say there is a, for an example, let's say you want to make a network query to the third party API. So at that time, you do not want to wait for like your code to execute. You can wait like, okay, that API is running like which you are making. So at that time, you can use the async. But when you do not need async, at that time, you can just run your functions into thread pool.
Thanks.
Any questions? Yes.
So whatever request will come to Fast API, G Unicorn web server, it will go to UV loop or what?
So there are two servers. One is Gunicon, another one is UVCon. So UVCon is basically giving the capability to use the ASGI, like asynchronous gateway interface. So your request will come like asynchronously. You can just use it asynchronously. You do not, your API will just not wait. It will just put it into UV. So if you are using UVCon, so what it will do, it will put it into UV loop. Then UV loop will take care of executing each request. So request come into your UVCon server, and it will put into a queue into your memory where your UVCon is running this fast API process, like whether it's Linux or like as a containerization.
So in microservices architecture, if I'm using Fast API framework, and one service is calling another service, and that time if I'm not using async await, I mean, because I don't know, like, whether that service is asynchronously implemented or what. Still, it will go to UV loop or what.
Yes.
So
Yeah. So at that time, what will happen? UV loop still come into the picture, but in Python, you can just define your functions as well. So let's say you created a function. There are two methods. One is in normal method, you will just say def this function, and you have written your code to hit an API to your other microservice. So if you have written your function into that format, so at that time, that function will execute as a thread, but still UV loop is taking care of it. Like there are two things. One is your main Python function, which you have defined with asynchronous or not, and another one is your function, which is actually making a query to the microservice. So if you had not used the async keyword with your function, so at that time it will run it into the thread pool. Otherwise, it will be taken care by the UV loop.
and UV loop is also handling a lot of requests, right?
Yeah.
I mean, unlike Django WSGI web server.
Yeah.
So is it maintaining any request pool somewhere, like, where we have to respond, because it is handling a lot of requests, right, at
Yeah.
the same time. So how it is handling the responses?
So,
Yeah.
yeah, it will create like a kind of a queue into your process. Let's say you are running your fast API. Let's say for an example, you are running with UVCon. So what UVCon will do, you have said like, okay, use the UV loop. So what UV loop's responsibility is to maintain that queue. It is not fast API or UVCon's responsibility. So what it will do, it will create a queue in your process, into your Linux processes, a queue, and it will put the request there. So for a worst case scenario, if your container crashes, then in any kind of like whichever frameworks you are using, it's just crashing. So you will know